So how do we save that? We use the reranking technique, and currently the most the leading approach is called cross encoder. A re-ranker is a model that reads the question and the document together. It acts like a strict teacher grading an essay. It outputs a relevant score from 0 to 1. So the pipeline is that we firstly use either dense or sparse to retrieve top 50, and then we use re-ranking. We re-rank this top 50, but slow but accurate, and then we keep top 5, and we only use this top 5 to feed into the LM in couple with the question to generate the final answer. So standard cross encoder are slow because we all know that the basic reranker can be implemented by just using BERT. I think everyone knows BERT, right? BERT we have taught it before in our previous lecture, and one of the BERT one way of using BERT is that we can put the question and then we put end of sentence and then we put the document, and we can see this if these two are similar enough, and we can use the COS token in the beginning as the input and classify it to 0 or 1, or we can put a regression layer here to let it output a value between 0 and 1. So that is how can we use BERT to implement cross encoder, but they are too slow because you need to compute this you need to compute it one by one in the inference time, because during inference you need to compute the query and document 1, query and document 2, query and document 3, 4, and the blah 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 50 times. Yeah, and you know that computing BERT requires GPU, and GPU consumes your money. Yeah, so can you think about that? You just repeatedly compute the documents. Even this document has been searched by other guys, you still need to compute it again every time. So one research team proposed the CowBERT, which is the short, which its longer form is called contextualized late interaction, offers a middle ground. It keeps token level embeddings and performs a maxim operation. So it allows us to visually inspect with word in the document matched which word in the query, providing explainability. So let's see how it works. Firstly, we use a BERT encoder to encode query. We use another BERT encoder to encode document, and they share weights. So the text becomes a list of vectors for each word, each token, and the document chunk becomes a list of document token embeddings and then we compute any one of them. So it's m multiply n. Yeah, so we actually find the maximum value for each position, each token, each query token. Then we can get this document score. So can you see that? This part can be reused. That's it. That is the most important spirit. This part can be reused. Every time, we don't need to recompute it. We can just compute this the document embedding document token embeddings for each document offline and store it. And when the runtime, we just need to retrieve it out, and we need to in the runtime, we just need to compute the query token embeddings on the fly, and then we only need to do these late interactions during the runtime. So what should we do in the runtime? We only need to retrieve the top 50 documents document token embeddings here, and we just need to compute query token embeddings. We just need to perform late interaction for the query token embedding and each document token embedding. So if we are going to re-rank 50 documents, we only need to do 50 late interactions 50 times. And we just need to do a BERT encoding one time. Yeah, that saves a lot of computing, right? So that will make the computation much more efficient and save your cost. Yeah, so this is the formula. And let me tell you why length does not equal to score, because if we enlarge the formula here, score, query, and document, and the key is that the summation is limited by query length, not document length. Yeah, so for example, if we have a query, we have two documents, and document A is short. It mentions, and our query is iPhone, Apple iPhone. The length is 2, and the document A is Apple phone. So token. So for query for this Apple, it matches Apple, and the max score is 1.0. And for this iPhone, it matches phone, and the max score is 0.8. So this is the score for document A is 1.8. And how about the score for document B? So the document B is long, and it repeatedly mentioned Apple, and iPhone. So suppose it matches 100 times of Apple, but the max score is just 1, because we only calculate we just score based on query length. So this Apple only has one part. It cannot takes 100 times. So for this part, the score is 1, and for this part, the score is also 1. So document wins because of precision. iPhone versus phone, not its length. Okay. Yes. Okay. Okay, so another trick is called context compression. Even relevant documents have fluff. So we have tools like long LM Lingua compress the prompt. It removes stop words, the is, and at, and the redundant information, reducing the prompt size by up to 80% while keeping the core facts. This speeds up the LM generation significantly. Okay, let's enter into part 6, agentic reg. So let's compare the difference between passive and active reg. So our naive reg is a passive reg. Passive reg. It's linear from the input search and then answer generation. So if search fails, the system fails. But for active or agentic reg, it's a loop. So the model creates a plan and adapts. So one of that agentic reg is called self-reg or self-reflective reg. In self-reg, the model is trained to output special reflection tokens. It critiques itself in real time. So it can output one of these three. If it outputs retrieve, then it means that it questions itself: do I need external data? And if it generates its relevance, then it means that it thought itself as, is this document relevant? And if it's sub output, that means is my answers supported by the text. If the check fails, it automatically triggers a research. Yeah, so you can read this paper published in ICOR for the details. And another approach is called C-reg or corrective reg. C-reg introduces a lightweight evaluator model. It judges the quality of retrieved documents before generation. So if the documents has good quality, then it proceeded to generate. And if the documents were ambiguous, then it performs a web search to verify. And if the document is in bad quality, then it discard and rely on logic or web search. So actually, the metaphor is that it builds a safety net around your data. So in part 7, we are going to talk about the structural reg called graph reg, which is designed to see the big picture. So vector reg is great for needle in haystack, like finding one specific fact, but it is terrible at summarizing the haystack. So we may ask a question like, what are the recurring themes in these 1,000 user reviews? And the vector search will just get you 5 random reviews. It cannot synthesize over this whole 1,000 user reviews. So graph reg is going to structure from chaoses. This is proposed by Microsoft Research. It has 4 steps. First, it pulls out entities. So what is entity? Entity is like people, places, and relationships. And it builds a knowledge graph based on these extracted entities and relationships. And then it detects communities of related nodes. So we can see that their algorithm will group a set of nodes to become one community. So all documents will be grouped into several communities, and then finally it pre-generates summaries for each community. So for each community, it has a summary. So that is a hierarchical way to find or to globalize the outcome. And this code, GraphReg, how do they do entity extraction? Actually, in their code, in their GitHub code, they use ChatGPT to process the text and extract entities and the relationships. So if you want to apply GraphReg, you may need a OpenAI ID. Then you can API key. Then you can do that. So GraphReg is actually a little bit expensive because it need to use GPT API to process all your documents before using it. So I don't know if any new implementation can let you select your own local model, but if you know that, you can tell me. Yeah, I can update my information. Okay, so how will GraphReg do in action? When answering a global question, it doesn't search for keywords. It looks at the community summaries. It can say there are 3 main complaints: A, 30%, B, 50%, C, 20%, because it has information from the community summary. And it provides a hierarchical overview that flat vectors can never achieve. Okay, so I think this idea is very popular in 2024. Yeah, but you can keep in check of the latest or recent advance of GraphReg. So finally, we are going to talk about evaluation and the conclusion. So how to measure the success of REG? So firstly, I co-work with many CS students or programmers or engineers in this recent 2 years, and I found that most engineers test their models performance by their eyes. They just take a look at the output and say, "Oh, it looks okay," but they don't have a systematic way to measure how success it is, how successful your model or your system is. Yeah. So actually, your intuition of or your vibe is not reliable. Maybe for a historical literature reg system, you look everything good, but maybe there are a lot of hallucinations among it. But you don't, because you are engineers, you don't have expertise in that domain, so you cannot detect these hallucinations. Or actually, the answer does does not correspond to the question, but because you are not expert, so you don't know if they have correspondence. So we need a framework to do that, and a team invented a RAGAS framework. It's the short term of retrieval augmented generation assessment. It uses Judge LM to score your system. So let's take a look at the reg triad. So for a reg, to consider the success, how success a reg system is, we need to consider three aspects. First is context precision. Do we did we filter out the noise? And second is faithfulness. Did the LM stick to the facts? So it is also can be considered as hallucination check. The third is answer relevance. Did we actually answer the user's question? So for traditional Chinese, ragas works, but you must supply a Chinese prompt to the judge LM to ensure accurate grading. Okay, so so let's go into our summary. To build a reg system in 2025, the naive reg is not enough. You need to try like structural way, like raptor or small to big indexing, or an hybrid. You must need to combine BGEM3 and the sparse indexing like BM25, and you need filter or a re-ranker. And the leading re-ranker is called BERT. But for Chinese, it's BGM3, and you also need to consider bring the concept of agentic into your reg systems design. Yeah. So finally, my advice is that do not blindly copy English tutorials. Pay attention to tokenization. Use BG is for research, but not if not, then you need to consider other solutions. I know that Microsoft has another embedding, so maybe you need to use that for if your system is not just for research, if your system is need to open to the public, then you can't use BGM3. And when your system has been constructed, you must evaluate your system with a framework or benchmark like Ragas. But remember that you need to modify its original English prompt into Chinese prompt. Thank you. Do you have any question about today's lecture? Okay, if no, please submit your notes I think I give you before 4 o'clock. Yeah, so for now you can write your note and then submit to the and send it to the TA. Thank you.
Okay.